Okay, we're moving on to graphing quadratic piecewise functions. And we've graphed piecewise before when we did linear functions. And so we're just going to review some things we already know. These are steps to making a piecewise function, to graphing them. First thing we do is we make a table for each equation in the piecewise function, choosing x values that lie within the domain. We want x values that lie within the domain. In other words, x values that follow our restrictions on our domain. If the function is quadratic, then we have to also find the vertex and add it as one of the points to be graphed. Then we actually graph those points. We choose whether we have an open circle or a closed circle on the breaking point. And if it's greater than or less than, your graph extends to the right. If it's less than or equal to, it extends to the left. Okay, the arrows point in the direction that it goes. So the best way to explain piecewise is actually to just do piecewise. And I'm going to do this first equation on the left, and I'll do the second equation on the right for all of these. So I'm going to start with this one. Remember, f of x and y are the same thing. So this first equation is y equals 2x plus 3. And my domain limitation is that it's only x's that are left or to less than -1. So this is not quadratic, this is linear. So I need to list values that include -1 and then go to the left of that. -1 would be here. That needs to be one of my points because that's the starting point or the breaking point. And then everything else, if this is it where -1 is, all the points of this graph are going to be to the left of that. So I have -1, -2, -3, and -4 are all points that would fit that. And then we plug those into the equation and solve for y. So if I plug in -1 for x, 2 times -1 would be -2, plus 3 is a +1. If I plug in -2 for x, 2 times -2 is -4, -4 plus 3 is -1. If I plug in -3 for x, 2 times -3 is -6, -6 plus 3 is -3. And if I plug in -4 for x, -4 times 2 is -4, -4 times 2 is -8, plus 3 is -5. And I'm going to plot these points. I have -1, 1, -2, -1, -3, -3, and -4, -5. Okay, and these are going to form a straight line. One of the things we need to remember though, since there's no line underneath my inequality, that means that this is an open circle at that endpoint. The endpoint is the one that includes, tells you where your domain is starting. So my endpoint is where x is -1. So this very first point is an open circle. That's the only place you're going to have an open circle is on the breaking point. And then again, I'm graphing everything on the left side of that breaking point. I'm not going to extend it to the right because this tells me it's only valid to the left of -1. So those are the only points that I'm going to graph on for that line. Now we're going to come over and do the second one. This one is quadratic because I have a degree of 2. So this is y equals x squared minus 6x plus 2. And it's true for the domain of x is greater than or equal to -1. And what we know about this one is since there's an equal to sign underneath the inequality, this endpoint or breaking point will be a closed circle. When we get to that point, we'll make sure that we fill it in. Since it's quadratic, remember if we have a quadratic, we have to find the vertex. This is in standard form. So to find the x of my vertex when it's in standard form, I take -b or the opposite of b over 2 times a. My b term is -6. The opposite of -6 is +6. My a term is 1. There's a 1 in front of the x squared, so that's 2 times 1. That gives me 6 over 2, or 6 divided by 2 is 3. So the x of my vertex is 3. Now to find the y of my vertex, I take that and I plug it into the equation. So I have y equals 3 squared minus 6 times 3 plus 2. 3 squared is 9. 6 times 3 is a -18 plus 2. 9 minus 18 is -9 plus 2 is -7. So my vertex is at -3, -7. Or excuse me, +3, -7. It's over 3 and down 7 right here. So that needs to be one of my points, needs to be at +3. One of my points needs to be -1 because that's the breaking point. One of my points is going to be a 3. And I'm probably going to pick 2 points on either side of this vertex to get an idea of the shape of my parabola. And I'm going to pick -2 and 4, excuse me, +2 and +4. And you can pick anything you want as long as it's to the right. Right? These values are all going to go to the right of -1. And you want to surround your vertex so you can see the shape of the parabola. So if I plug in 2 for x, you have y equals 2 squared minus 6 times 2 plus 2. 2 squared is 4. -6 times 2 is -12 plus 2. 4 minus 12 is -8 plus 2 is -6. So at +2, I have -6. 3 is -7. 4 is going to reflect on the other side and also be -6. Now I need to know what it is at -1, so I need to plug that in to get my y. So I have -1 squared minus 6 times -1 plus 2. Remember that when we square a negative, that makes it positive, so this is +1. -6 times -1 is a +6 plus 2. So I have 1 and 6 is 7 plus 2 is 9. So at -1, actually, -1 plus 6 is 7 plus 2 is 9. So that means I've got -1 and up 9. So it goes all the way up there. So look how steep this parabola is. It comes around here and it goes all the way up there. And what we need to remember is that this is an end point or breaking point. It's where it starts. I'm not going to, so there's no arrow going up. This, however, is going to continue off to the right, so I do have an arrow on this side. So the blue is the first equation, and it's only valid to the left of -1, but not including it, so it has a circle. The purple is the parabola to the right of -1, so there's no points to the left, but it has a closed circle where it hits that breaking point. So that's our first example. We have a linear equation and a quadratic equation. Make sure I got this going right here. We go. We have linear and quadratic again. These are different lines. Again, I'm going to do the first line in the blue. This is y equals 4x minus 3. This is the linear one because I have a degree of 1. My domain limitation is x is greater than or equal to 1. Because I have the equal sign under the greater than, this is a closed circle at my breaking point. And this is going to be true. If this is +1, it's only going to be true to the right of +1. On my purple, I have a quadratic equation because I have a degree of 2. So this is -2 times x plus 3 squared plus 4. My domain limitation is x is less than -1. Because there's no equal to sign under there, this one is an open circle. And this is only true from -1 to the left. So there's going to be a gap here between -1 and +1 where I don't have any graphs at all. So let's focus on just the blue one, on the first one. It's linear. My starting point is at +1, and I'm going to the right. So I'm going to start at 1 and pick, because you want the one that's actually part of the domain limitation, and then everything to the right. So I have 2, 3, and 4. I'm going to plug those in to get my y values. 4 times 1 is 4, minus 3 is 1. 2 times 4 is 8, 8 minus 3 is 5. 4 times 3 is 12, 12 minus 3 is 9. And 4 times 4 is 16, 16 minus 3 is 13. So if I graph these points, I've got over 1 and up 1, over 2 and up 5, over 3 and up 9, and I'm going to 12, 13, and over 4 and up 13 all the way up here. And this is our straight line, and it continues off to the right, it stops here at positive 1, and it's a closed circle because I had a line underneath it. If there didn't have a line, then I would have a circle just on my breaking point only. For my parabola, I know I need to have -1 as one of my points because that's my endpoint. I also need the vertex. This is already in vertex form, which makes it really easy for me to see the vertex. It's the opposite of what's with x, so that's -3, and then my k is out to the side, that's my +4. So my vertex is -3, 4. That's got to be one of my points. And I need a point on either side of my vertex. We've got -3, 4. We'll go ahead and put that in here, -3, 4. So I'm going to put in -2 and -4 to have points on either side of the vertex. And I need to plug all of these in to find out what the y values. So if I plug in -1, I have y equals 2 times -1 plus 3 squared plus 4. -1 plus 3 is 2, so this is 2 times 2 squared plus 4. Remember, we square before we multiply, so this is 2 times 2 squared is a +4. Multiply before we add, so I have 8 plus 4, so now I have -1. Nope, see, I made a mistake here because we have this is a -2 on the outside. I'll carry that down. -2 times 4 is a -8, that's better. And -8 plus 4 is -4. It's a really good example of how you really have to pay attention to your negative signs. So -1 is down here at -4. I'm going to plug in -2. Y equals -2 times -2 plus 3 squared plus 4. I'm going to do what's inside the parentheses. -2 plus 3 is a +1. I'm going to square first. So this is -2 times a +1. -2 times 1 is -2. And -2 plus 4 is 2. So -2 plus 2, so -2 and up 2. If this is my vertex, this is going to mirror on the other side. And this is also going to mirror on the other side. So it goes up and down like this. But this breaking point, this means -4 is also going to be a -4. So this breaking point is at -1 is an open circle. So I'm going to go back here and make sure that that's an open circle. Okay, that completes this particular piecewise. The purple this time is to the left of -1. The blue is to the right of +1, which means I don't have anything in between those. The one without the inequality has the open circle. The one with the equals under the inequality is a closed circle. One other thing, and again, pay really close attention to your order of operations and making sure you're paying attention to negatives. Okay, the next one we have are 2 quadratics. So this will be fun. On the first one, I've got y equals 2 times x minus 2 squared minus 4. That's what I'm going to do over here. My domain limiter is x is less than 0. It's less than without an equal to sign, so that means it's an open circle. And it's less than 0, so this is everything to the left of 0. I need to have my vertex. My vertex, because it's in vertex form, is easy to see. It's 2, -4, because it's the opposite of what is with x, and then -4. So it's going to be one of my points. This needs to be changed to greater than. Let's do this. I think and if your teacher hasn't already told you, I forgot to change them in my notes. This is greater than. I forgot I had a set of the notes that didn't change that. So this is actually going to be greater than 1. Change these delimiters. Make this x is greater than 1. And this one is x is less than 0. So where this is 1, I'm going to go greater than 1. Okay, so now when I put in my vertex, I have over 2 and down 4. Okay, that's my vertex. I need points on either side of it. Clearly, if my delimiter is 1, that needs to be one of my points, so I'm going to have 1 and 2. 2 being my vertex. Then 3 is going to mirror it on the other side, and then I'm also going to need 4. So I'm going to start with 1. When I plug in 1 into this, I get y equals 2 times 1 minus 2 squared minus 4. 1 minus 2 is a negative 1 squared minus 4. Negative 1 squared is 1, so this is 2 times 1 minus 4. 2 minus 4 is negative 2. And that's going to mirror on the other side. So I have 1 negative 2 and 3 negative 2. And then I need one more point, so I'm going to plug 4 in. So I have y equals 2 times 4 minus 2 squared minus 4. 4 minus 2 is 2. I'm going to square first. 2 squared is 4, so this is 2 times 4 minus 4. And 8 minus 4 is 4. Lots of 4s there. Over 4 and up 4. Okay. This one is an open circle at my delimiter. I'm going to get my parabola in here first to the right of 1. And then at the starting point, or at my breaking point, I'm going to have an open circle because I don't have a line underneath it. And so that's that parabola on that side. The second one is going to be y equals negative x squared plus 1. My x is going to be less than 0. Again, no line underneath the inequality, so this is also an open circle. Okay, all the ones we've had till now, we've had one open circle and one closed circle. That's not always the case. Sometimes you have 2 open circles or 2 closed circles, so just pay attention to what your domain limiters are. And I know I need to plot my vertex. For this one, this is in standard form. So my vertex, to get my vertex, my x is going to be the opposite of b over 2a. I don't have a b term, so my b is 0. It doesn't matter what the denominator is because 0 divided by anything is 0. So the x of my vertex is 0. If I plug that in, 0 squared is 0, plus 1 will give me a y of 1. So my vertex is actually also my limiter. And it's at 0, 1. Then everything I'm going to do on this one is going to be to the left of 0, so I'm going to do negative 1, negative 2, and negative 3. I'm going to plug in negative 1. Negative 1 squared is a positive 1. And watch what this happens. Make sure you pay attention. This is a negative x squared plus 1. That's like a negative 1 times x squared plus 1. So when I plug in negative 1, I get negative 1. The negative 1 is being squared. Square first. If I square a negative 1, that's a positive 1. And it's being multiplied by that negative 1 on the outside. And that confuses people a lot. Negative 1 times 1 is a negative 1 plus 1, which equals 0. But be really careful. It's a negative 1 times whatever x squared is. When you square this x, it's going to be positive, and then the negative 1 means that after you square it, that negative 1 is going to make it negative before you add the 1 to it. So be really, really careful of that. So I have negative 1, 0. If I plug in negative 2 squared is a positive 4. I'm going to take that times the negative 1, which is negative 4, plus 1 is negative 3. So I have negative 2, negative 3. And if I plug in negative 3 squared is 9. The opposite of that's negative 9, plus 1 is negative 8. So at negative 3, I'm at negative 8. So this is this half of the parabola going down, except remember, this breaking point at 0 is not closed, it's open. So I'm going to go back and erase that and make sure it's clear that that's an open circle. And this one also has a gap between 0 and 1, and that's okay, because that's the limitations that were given to us. Okay, we have one more set of piecewise to graph, and that's exponential quadratic. This is the first exponential one that we've done. I'm going to do the exponential one in blue on this side. So this is y equals 2 to the x. And that my domain limitation is x is greater than or equal to negative 1. I'm not going to change your domains this time. This one's going to stay. So I have negative 1 to the right is going to be this one. I'm going to go through and start with my domain limitation, which is negative 1. And I'm going to pick, from that point to the right, I'm going to pick 4 points. So I have negative 1, 0, 1, and 2. If I take 2 to the negative 1, anything to the negative power means you flip it. So this is y equals 1/2 because you put it in the denominator, make it a positive. So this is 1/2 or 0.5. If I take 2 to the 0, anything to the 0 power is 1. 2 to the 1 is 2. And 2 to the second is 2 squared, which is 4. So I have negative 1 and up 1/2. I have over 0 and up 1. I have over 1 and up 2. I have 2 and up 4. And you can see how this is curving that way. And I made the mistake of drawing to the left of that. I can't draw to the left of that because I'm limited at negative 1. I do keep that a closed circle. This is closed because I have a line underneath my inequality. So that would be my exponential piecewise. I'm going to do my quadratic next. I have y equals 2 times x plus 2 squared plus 2. That's a lot of 2's. My domain limitation is x is less than negative 1. There's no line under the inequality, so that's an open circle. And we know we got to find the vertex. That's one of the points we have to graph. This is in vertex form, so my vertex is negative 2, positive 2. So I'm going to graph that first, negative 2, positive 2. This is true to the left of negative 1. So I have to have negative 1 as one of my points. I've already said negative 2 on my vertex is positive 2. I'm going to take negative 3. And since that's the vertex, that'll mirror whatever I get for negative 1. And then I'll plug in negative 4. When I plug in negative 1, I get y equals 2 times negative 1 plus 2 squared plus 2. I'm going to do the parenthesis, was in the parentheses first. Negative 1 and 2 is 1 squared plus 2. I square before you multiply, so 1 squared is 1. 2 times 1 is 2. And 2 plus 2 is 4. So when I have 1, this is 4, or negative 1, 4. Negative 1 and up 4. I'm going to mirror that on the other side with 3. I go 3 and up 4. And the negative 4 I'm going to plug in to get a value. I have y equals 2 times negative 4 plus 2 squared plus 2. Do what's in the parentheses first. Negative 4 plus 2 is negative 2 squared plus 2. I'm going to do the square before I multiply. When we square a negative number, it becomes positive. So negative 2 squared is a positive 4. 2 times 4 is 8. And 8 and 2 is 10. So at negative 4, I'm up to 10. So this quadratic is going in that direction. It stops at negative 1, but I know that it's an open circle, so I'm going to go back and make that an open circle. And that's my final piecewise graph.